So the last video of 12.1 was working through finding patterns and sequences. This video is called Summation Notation. Summation means to add. Think about the word sum. The sum of something is added up. And if you'll notice here, if I have a bunch of terms, the first term, second term, third term, all the way up to any random nth term, if I take those and add them up, I have a sum. And this notation is called the summation notation. And this symbol right here is called sigma. It's a Greek letter, and sigma is what we use to show that we want to add a bunch of things together. Now, in our homework here, or in our example, it says write out the sum. Now, writing out the sum means they want us to expand it out. They don't want the value, they want us to expand it out. And if you look here, there's a bunch of some new notation. First of all, there's a new letter. There's not just N, but there's the letter K. And K is just our index. It's the place that we're finding. So we're going to find the first place, the second place, the third place, all the way up to N. And so K equals 1 means find the first place, and then you would go to the next one, second place, third place, and you stop when you get here. This is where the reason we had to use the letter K down here is because we still have a variable. We're still plugging in. And so if I wanted to find the first term, that's finding K equals 1. So my first term would be 1 over 1 plus 1. Okay? And that's equal to 1/2. My second term, right? My second term would be 2 over 2 plus 1. So that's 2/3. And then we add that together. And because it goes all the way to N, we usually do 3 of them. It's very typical to do the first 3. So A sub 3 means find the third term. That would be 3 over 3 plus 1. So that's 3/4. And then we write plus dot, 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 meaning and so it continues. So 1/2 plus 2/3 plus 3/1 plus dot, 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 plus, and we stop at N. So if my nth term is equal to N over N plus 1, see how we put a 1 for the K, 2 for the K, 3 for the K, and now N for the K, then my last term here, we just write N over N plus 1, and that is how we write out the sum. Next problem works exactly the same way. We're going to go, notice the notation is different. Well, this one is what most of our textbooks use. Some textbooks use this notation, so I just wanted you to see it means the same thing. Our K starts at 1, that means find the first term, and go all the way into the nth term. So when we're finding A sub 1, we're going to plug in 1 for K right there. So that's 1 squared minus 1, that's 0. Plus, let's find our second term. We're going to plug in 2 for K. That's 4 minus 1 is 3. Plus, let's find the third term. 3 squared minus 1, that's 9 minus 1 is 8, plus dot, dot, dot. And then the last one, we're plugging in N. So that's just N squared minus 1. There is writing out the sum. Sometimes, however, they wrote out the sum and they want us to write the summation notation. So if we take a look at this, this is A sub 1, A sub 2, A sub 3, all the way to A sub 9. And how do I know that it's 9? Because the 1 matched, the 2 matched, the 3 matched, and the 9 matches. So this one, we're going to go from K equals 1 up to 9, because we've only got 9 terms. We go from the first to the 9th. But we still need our formula pattern. So let's over here on the side figure out what our nth term would be, A sub n. Well, up until now, 1 squared, 2 squared, 3 squared. So this is going to be n squared. And our pattern is n squared. That's our nth term. But what do we write here? We write k squared. We have now expressed this entire addition as a single summation notation. So instead of n in the pattern here, we put k because we are going from k equals 1 up to 9. And then we would plug in 1, plug in 2, 3, 4, all the way up to 9, and we would have our problem spread out. Let's take a look at this one. This one, the first term is 1, so it's k equals 1. And this last term, it looks like it might be the n minus 1 term. Only notice something. So this is 1 over 1. This is 1 over 2. 1 over 4, 1 over 8. That doesn't match the n anymore. This is a sub 1, a sub 2, a sub 3, right? And what you'll notice is this is really 2 to the first power, 2 to the second power, 2 to the third power. And so this is first term, second term, third term. A sub 4 was to the third power. So this is actually the nth term because our exponent was 1 lower than the term number. So we're going to say that we're going to go k equals 1 to n, right? I'm drawing my line right there. I'll rewrite it. We're going to say k equals 1 to n, and instead of 1 over 2 to the n minus 1, we're going to change it to 1 over 2 to the k minus 1. We now have the summation notation for this sequence. There are a few properties of sequences that we're going to be able to use this year, and I just wanted to show you. In your book, this is what you get. This looks very intense. It looks like a lot. But I'm going to put a box around the stuff you need to pay attention to, right here. If you have a summation, or you have some constant times a variable, you can simply pull the constant out to the front. Okay, example. See this 3 right there? We can rewrite that as 3 in the front of k equals 1 to 5 of k. So you can just throw the constant to the front and multiply it and work your answer from there. The second thing I want you to notice is that if we have two things added together, we can split them into two separate things. Like right here, I can split this into 3 different equations. So I'm going to write it as k equals 1 to 24 of k squared minus, I'm going to throw that 7 to the front, of k equals 1 to 24 of k plus k equals 1 to 24 of 2. So I had 3 terms, so I split it into 3 problems. I had one term with a 3 in front of it, so I threw it to the front. Now, once we have split it up, there's 3 things that could happen. Your term could have a constant, your term could have a single variable to the first power, or your term could have a single variable to the second power. That's all you're going to do this year. There's other things that can happen, but all you're going to do this year is constant, variable to the first power, or variable to the second power. And if you'll notice down here, this one's variable to the first power, this is variable to the second, variable to the first, and this is just a constant, the number 2. Okay? So, whenever you see a constant, all you have to do is multiply the constant times that n up here. When you have k to the first power, you're going to take that n up there, add 1 to it. So like let's say the n was 5, I would write a 5 there, and I would write a 6 there. 5 plus 1 is 6, divided by 2. And if the k is squared, we're going to do n times n plus 1 times 2n plus 1 over 6. So let's take a look at this first problem. We've split it out, but we still haven't found the sum. So that's the rest of this lesson, is finding the actual sum. So first of all, the number 3 is just 3. And we're going to multiply that by something, because it says 3 times all of this. This is k to the first power. So do you see this right here, k to the first power? We're going to say k uses n times n plus 1 over 2. We're going to remember that. K uses n times n plus 1 over 2. And in this problem, my n was 5. So that's going to be 5 times 5 plus 1, which is 6, over 2. We put that in a calculator. There's no need to do this by hand. We just do 3 times 5 times 6 divided by 2, and we find that that is 45. Now, what does that mean? It means if I listed all 5 of the first terms, if I wrote first term, second term, third term, fourth term, fifth term, and I wrote them all out, which would be 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and so forth up until the fifth one, and I add all those together, I would get 45. So this is the sum of all of the terms when we plug in from 1 to 5. So this one they're asking me to find 24. See, if it's just 5 of them, we can do that. 3 plus 6 plus 9 plus 12 plus 15, we add them up, we get 45, no problem. But this one wants 24 of them. That's quite a few. We'd have to plug in 1, 2, all the way to 24, add them all up, that's a lot of work. But when we split it, let's look at how we can do this. K squared, we look up here, K squared uses n times n plus 1 times 2n plus 1 divided by 6. So n is 24, n plus 1 would be 25, double that is 48, plus 1 is 49, divided by 6, minus, I'm going to do 7 times, and then we have k uses this one again. So that's 24 times 25, all divided by 2, plus, this is the constant, and the constant uses c times n, okay? So we're just going to multiply the constant times 24. We plug this into our calculator, and the sum of this one is 2,848. It might seem like a lot of work, but it's certainly a lot less work than finding all 24 terms and then adding them up. So, once again, k uses n times n plus 1 over 2. K squared uses n times n plus 1 times 2n plus 1, all divided by 6. And constant, anytime you have a constant, it uses constant times n. Good luck with your homework.